Detail about heat exchanger. Heat transfer is the process of thermal energy being exchanged between two or more objects or systems. This energy transfer occurs as a result of a temperature difference between the objects or systems, and it always flows from hotter to cooler regions until thermal equilibrium is reached. There are three modes of heat transfer. Conduction. This is the transfer of heat through a solid material due to the transfer of energy between adjacent molecules. The rate of heat transfer through conduction is determined by the thermal conductivity of the material. Convection. This is the transfer of heat through a fluid, such as air or water, due to the movement of the fluid itself. Convection can be natural or forced. Radiation. This is the transfer of heat through electromagnetic waves, such as light or infrared radiation. All objects emit and absorb radiation, and the rate of heat transfer through radiation is determined by the temperature and emissivity of the objects. Uses of heat transfer include heating and cooling systems for buildings and vehicles, thermal management of electronic devices and machinery, industrial processes such as metal casting and food processing, power generation in steam turbines and nuclear reactors, cooking and food preservation. The units of heat transfer are joules, J, or calories, cal, and the formula for calculating heat transfer is Q equals mech delta T, where Q is the amount of heat transferred, m is the mass of the material, C is the specific heat capacity of the material, and delta T is the temperature difference between the initial and final states. Detail about mass transfer. Mass transfer is the process of the transfer of mass or substances from one phase to another phase, usually from one fluid to another fluid or a solid. The transfer of mass can occur through different mechanisms, such as diffusion, convection, and mass transfer due to a chemical reaction. There are four types of mass transfer. Diffusion. This is the transfer of mass from a region of high concentration to a region of low concentration due to the random motion of molecules. Convection. This is the transfer of mass due to the movement of a fluid. It can be natural or forced. Mass transfer due to a chemical reaction. This is the transfer of mass that occurs due to a chemical reaction between two or more substances. Electrical migration. This is the transfer of charged species due to an electric field. Uses of mass transfer include separation of components from mixtures in chemical industries, extraction of materials from liquids, filtration of particles from gases and liquids, purification of impure materials. In wastewater treatment plants, the units of mass transfer depend on the type of mass transfer being considered. For example, the units of diffusion are square meter per second, while the units of convective mass transfer are kilogram per square meter s. The formula for calculating mass transfer depends on the type of mass transfer and can be quite complex. For example, the formula for diffusion can be represented by Fick's law. J equals d, dc, dx, where J is the molar flux, d is the diffusion coefficient, c is the concentration, and x is the distance.